Hello everyone, greetings from South Africa. As promised last time, I'm going to talk more about our energy system today. Last time we fitted the solar panels onto the roof and connected them into two circuits. And now we have to run cables down into the engine room in order to transport the electricity into the inverter and the batteries. However, Gambia is either extremely sunny and therefore hot, or extremely rainy and therefore wet. So I didn't want to run the cables in the open, and we built covers to solve that problem. We used a simple 2-inch drainage piping and knees, and built the covers that you can see here in the picture. From there, we went into the engine room. The cables were into the engine room on top of the door frame. We run the cables in empty piping so that we can see if there is damage and that the heat that potentially comes up dissipates. And what you can see here now is the first interesting piece in the engine room. This is the fuse box for the solar panels. It has, of course, direct current fuses because solar panels provide direct current. What that is compared to alternating current is something that I can describe if you're interested in a separate video. You can see that we have 4 fuses in total in the fuse box, split into 2 sets of 2. Each set is for one of the solar panel circuits, and as you can see, both sets have one plus and one minus, red cable, black cable. And that makes sense because if there is a problem in one side of the array, both fuses trip at the same time and the entire array gets shut down. It's pretty much a safety measure to double up here. Then both solar circuits run into the inverter. The inverter is pretty much the brain of the entire setup, and it converts direct current into alternating current and vice versa. Again, if you're interested in knowing the difference between alternating current and direct current and why both have advantages and disadvantages, I can make a separate video for that. The inverter is also connected to our battery setup. As you can see here, it's quite the big boy. We have the bottom 4 boxes, which are the batteries. Each box holds a lithium-ion battery with a capacity of 2.5 kilowatt hours, which is quite a lot. You can run an average stove for 2.5 hours with one of the batteries. The top box is the brain of the battery. It communicates with the inverter and leads the charge and uncharging of the batteries beneath. You can also see it is independently fused and it has a power button to be switched on and off. The battery, is of course connected to the inverter for charging, uncharging and communication. And then we are coming to the last piece in the puzzle, which is the fuse box. Our inverter provides us with 3-phase alternating current. Again, if there is interest, I will make a separate video. What it means pretty much is that we have 3 wires that carry the energy to the point where it is needed, and 1 wire that transports the empty energy, so to speak, back. You always need 1 wire that goes to and 1 wire that comes back. And as you can see on the left of the fuse box, we have 1 fuse for these 3 wires that transport it to, and for the 1 wire that carries it back. Therefore, 4 fuses. Afterwards, as you can see on the right, we have 3 more fuses. We did that in order to split the 3 wires that transport the electricity into 3 individual circuits. And yeah, we gave it individual fuses because we can size the fuse to the demand that we have. And if one of the circuits fails, it doesn't trip the entire system, but only the fuse of the circuit that is affected. Therefore, the rest of the system still has electricity. We split it into 3 circuits because we have different requirements. As an example, the first fuse is to supply the administration building with electricity. One fuse was supposed to supply the pump with electricity, but what happened there I will describe in a later video. And we have one fuse that is going to supply the stable building with electricity and other power needs that we might have. And that is the engine room. Next time I'm going to talk more about the electrics of the administration building, so pretty much what happens after the left fuse. Talk to you then.